Welcome back to our series of videos. Here we are with a concave mirror. As has been described before, the laws of reflection states that the angle of incidence is always equal to the angle of reflection. So based on that principle, on a curved surface, as we have seen in the concave mirror, when a parallel beam of light is incident on a concave mirror, they got reflected differently because the normal to the surface for each point on the curve is different. For instance, for this ray of light, the normal will lie somewhere around here in this direction. Therefore, the angle of reflection or the reflected ray will go in this direction. For this particular ray of light, since it is incident normally to the surface, so there is no bending of beam. The reflected ray traverses simply back to the same direction. And again, for this ray, being incident on this surface, the reflected ray will follow this direction. Now, there is an interesting point where all these reflected rays of light meet. This point is called the focus, and the distance from the optical center that is inside the concave mirror is called the focal length, where images are formed. So depending on the location of the object, the image will be formed differently. Now, having understand the pattern of image formation by a concave mirror, we have varieties of applications. For example, the mirror that we use for shaving, it gives a magnified output. That is the reason why we use concave mirror. And in the headlights of vehicles, we use concave mirror in telescopes, microscope, and so on. Now we will focus on convex lens. Here we see the phenomenon of refraction. A light ray entering the lens at this point got refracted or got bent in this direction, which is also governed by Snell's law of refraction. The light ray that is entering normally here travels a straight line, and the light ray entering at this point bent in this direction. So the point at which these light rays meet is called as the focus, and the distance of the focus to the optical center, which is inside the lens, is called the focal length. So depending on the position of the object, just as we have discussed in the concave mirror, image formed by a convex lens are either magnified or diminished. So depending on the various type of application, we can use them for magnification or demagnification of objects. Convex lenses are also used in camera, microscope, telescope, and magnifying glasses. And naturally, our eye is also working using a natural convex lens. Thank you.